Alright, so in this video clip, we are going to explore the segment results we just created. So select the cluster node and go to exported data right on the general tab, and it allows us to see the change in the data set. So there will be a new column just being created indicating the membership, the cluster membership for each observation we have in the data. So select train because we haven't split it, our original data set into train and validation set. Every data points are under train. In explore, right, so under this table, the last column is the segment membership. The first observation belongs to segment 5, segment 5, 5, 5, and then this one belongs to 7, and so on and so forth. Right, so let's generate some plots. And we're gonna plot the 33,000 something observations on two-dimensional space using their XY coordinates. And we're gonna superimpose the membership, cluster membership of each data point. To do that, go to Actions, Plot, and we're gonna create a scatter plot. And we are using longitude and latitude information, and segment ID, use it as a color, meaning that we're gonna color code by their segment membership. And make sure you allow multiple role assignment, and these three we will choose their role as tip. So it's just useful. When you locate your cursor on any point, it will display the exact value of household size, household income, and regional density. So that's what it's for. And then finish. And you have this plot, but looks like the marker size is kind of too big. So right click, and here we have auto size markers. Disable it. I'm gonna reduce it to like 5. And okay, it looks much more professional now. Along with this color-coded sort of graph, I am also going to create a bar chart of cluster membership using the cluster information as a category. It's a categorical variable. Cluster 1, cluster 2, cluster 3, and finish it. So segment 4 accounts for this many observations, and then followed by segment 7, and so on. And view and select tile, and I'm gonna exit all the other windows other than these two, and then select tile again. And now you can see them alongside. So when I zoom in, let's say this portion of data points, the zip codes on the West Coast, the selected area are sort of reflected on the other graph. You can see them, the shaded parts. If I select another region again, so this part we have much of them, many of them, they come from cluster 4, segment 4. So these two graphs are connected. So if I select here, and then you can corresponding change on the other graph. So let me exit all this. And what I am going to do next is I'm going to add one more node named segment profile. It helps us to profile each cluster we have. So that is under Assess Tool, and segment profile, the last one. Place it. and connect cluster to segment profile. And here select variables under train heading. Select the ones we'd like to use to profile or describe the clusters you have. So I am going to use the three inputs we originally used to generate 10 clusters. So these three I am going to use, yes, to generate profiles of each cluster we have. And other than that, except the distance, distance is basically, it's already rejected. It computed the distance between each cluster, and data points and between data points and everything. And we don't need to worry about because we have the cluster membership already. But I am going to change to no for these, and also this one. We are only using the remaining to describe the clusters. And OK. And run. So this tool enables us to compare the distribution of a variable and an individual segment to the distribution of the variable overall across all segments. So that is the merit of this tool. Okay, so let's look at the results. So we will look at profile window first, and I'm going to maximize each segment. They are by sort of descending order of their size. Segment 4 is the largest cluster, followed by 7, 10, 1, and so on. For the given segment, these are the inputs, and they are displayed by the order in which this one is the most important one to describe and characterize segment 4, and second most important one, and third most important one. The way we interpret, let's say, this out of this graph, basically compared to the overall distribution of regional density percentile, which are noted as the red, the boxes, evenly distributed across all. That is from the population. The segment 4 has a relatively lower regional density percentile because the entire mass is located at to the left of this distribution. So segment 4 has lower density, regional density percentile than the population. By the same token, for segment 4, basically that has this time slightly higher average household size than the population, because the blue bar is slightly to the right of the red one, the population one. And this one it's a bit tricky. I would say because we have more masses, the empty red box is to the right. So segment 4 has lower median house income than the population. You can also you know, generate such descriptions for other segments. For segment 7, um, has segment 7 has a higher regional density percentile than the population. So this is the way we sort of describe each segment in terms of the inputs we used. Let me restore this window and look at this variable worth window. So again, segment 4, 7, 10, they are by the order of the size. And this window shows the relative worth of each variable in characterizing each segment. So for example, segment 4 is largely characterized by regional density percentile and mean household size and mean household income sort of play a smaller role. That's same for the segment 7, although the order between these two are sort of reversed. If I scroll down, segment 1 is actually largely characterized by mean household size, followed by regional density. So depending upon segment, I mean, sort of different inputs play different roles in characterizing them. Okay, that's it.